Okay, quick review of proportions here for a minute before we go into our cone. Proportions are when two fractions are set equal to each other and that they are equal. And so it comes up a lot when you are dealing with similar shapes. So like if these two shapes are similar, and I tell you that they are similar, and let's say I know that this side's 5, this side's 12, and that this side I don't know, but this side's 8. And I tell you the shapes are similar, we can set up a proportion to show or to figure out how big that side is, because in similar figures these are going to get bigger or smaller at the same rate. So I can say, well, 5 and 12 is the ratio between those two sides. And so if I line those up with my right-hand side, then I can say x is to 8 in the same way. Those two fractions need to be the same, otherwise they're not going to be similar. So if I solve this proportion by multiplying by 8 here to get x alone, I get 40 over 12, which ends up being, see if I can find it really quick, 40 over 12 is 3 1/3. And so then that right there is 3 1/3. Now that's just a quick review of something we're going to use with our cone here. I'm trying to see if I can erase everything without just scribbling. Looks like I'm just going to get to scribble. So when we are trying to find the surface area of a cone, just like with all the other ones, we have to picture what shapes these are when I flatten it out. And so if you look at a cone, we have the circle on the bottom, and then if you flatten out the pointy part of that, it actually ends up being this crazy pizza slice. And so we know how to find the area of that circle. It's just pi r squared, but we don't know how to find the area of that. We don't have a formula for it. And so what we're going to do is I'm going to show you where the formula for area of a cone comes from. And I just want you to keep in mind that eventually, if you just know the area of a cone formula, then you'll be fine. But I want to show you where it comes from. So what I'm going to do is I'm going to make this pizza slice into a bigger circle. And it has a radius right here, but I'm not going to call it R because I already have an R on my little circle, so I'm going to call it S. Now as you look at that S is the same as this 18 right here in our picture. It is called the slant height. It is not the height of the cone, because the height of the cone would go straight through the tip all the way to that radius to make a height. This 18 is called a slant height. And so we're going to use that S for a minute on our big circle. And what we're going to do is we're going to set up a proportion. And we are going to compare the area of the whole circle to the area of that pizza slice that we don't know. So the area of the whole circle is pi r squared, but my r is the slant height. So pi s squared. And I'm going to compare that to the area of the pizza slice. I don't know what it is. And then we're going to compare that to the circumference of the big circle. So circumference ends up being pi times 2r. But we don't want our r of that big circle is actually s. So I've got pi times 2s. Compared to the circumference of the pizza slice, and I'm going to say circumference with quotes around it because it's not really the circumference, but it's the edge of that pizza slice. Do I know what the edge of that pizza slice is? Turns out I do, because of this circle that I have down here. This circle would line up with that edge of the pizza slice, which means if I know the circumference of the little guy, it matches up with the edge of the pizza slice. So how to find circumference of that one is you take pi times 2 r, because now I'm dealing with the little circle instead of the big one. Now again, I'm going to pause here for a minute. Eventually, we're just going to get a formula for this. I'm just trying to show you where this formula is coming from. So if I try and solve this big proportion down here, this equation, I can start doing some things. I can just take a look at the right-hand side. I'm going to cancel out the 2 and the pi. And that's all I'm going to do now. So I have pi, s squared over my pizza slice that I don't know equals s over r. And so I need to solve this equation for my question mark. So let's see how I want to do this. Let's times by the question mark first. And so I get pi s squared equals s times question mark all over r. Let's see if I can do something here. Yeah, I can kind of make it smaller. Okay, cool. So then I get to multiply by r on both sides. So it's r times pi s squared equals s times question mark. We're getting closer to finding our question mark. So divide by s, and you get r pi s, because one of those cancels out with that one, equals our question mark. Now what was our question mark? It was our crazy pizza slice area. Well, guess what? Now we know how to find the area of a cone. We take our r pi s, which is our crazy pizza slice, and we add the little circle, because this was what our cone was when we flattened it out. So it's pizza slice plus circle gives us the surface area of a cone. So should we try it? Keep making this smaller and smaller. All right, let's see. Using our formula and this cone right here, let's see if we can find the surface area. So r is 7.5 times pi times the slant height of 18 plus pi times 7.5 squared. So you're going to want to grab your calculator and get 7.5 times 18. It's 135 pi plus 7.5 times 7.5, 56.25 pi. So add those together and you get 191.25 pi. But again, I think in your homework, I'm going to have you times that by 3.14 and get an approximate answer, which is 600.525. So pretty cool, right? Main thing to know is this formula, but I wanted to take a minute and show you where it came from. So use that on your assignment.